Hello everyone, welcome to the Binance Chain Club. In today's video, we are continuing our series on building a real-world crowd sale on the Binance Smart Chain. This is the last part of the series, and it will focus on building a prototype ERC20 token and crowd sale with smart contracts that can be deployed to the Binance blockchain in order to raise funds in an ICO. I'm going to walk you through each step in the process of developing this smart contract and deploying them to the live network. In this video, we will cover the following topics: the technical solution overview on ICO, the ICO system design, its smart contract functionality, and lastly, the implementation walkthrough using Remix IDE. It is important to note that this video requires some fundamental knowledge about blockchain and Solidity programming. If you need a refresher, we recommend checking out the previous part of this series. And without further ado, let's first talk about ICO as a solution. The traditional approach of raising funds for startups through VCs financing is often a painful and time-consuming process due to the extensive due diligence conducted by VCs before issuing a term sheet. According to a survey conducted by Harvard Business Review, the findings suggest that the average time taken for VCs to close a deal is about 83 days. Startups are required to wait at least 3 months before they can receive their first tranche of funding from VCs. Even if these early-stage companies manage to secure funding from VCs, the cost of capital may not be optimal. Apart from VC financing, an alternative source of funding is business loans from financing institutions. These loans often require borrowers to pledge collaterals of similar value as a principal amount requested. The collateral requirements imposed by financial institutions create a significant barrier to such loan facilities for startups that adopt asset-light strategies or service-based business model, since they do not have sufficient collateral to secure the loan. Other factors such as short business history, which makes it hard for lenders to gauge startups' ability to repay the loan, have also contributed to the problem of inadequate access to funding for startups. Startups generally have limited access to capital, and the financing options that are available often involve lending processes and proactive engagement with prospective investors. To improve access to capital and reduce the overall time taken to receive funding for startups, an ICO service may serve as an alternative to the traditional financing vehicles. ICO strength lies in the relatively low regulation standards, which allows us for a fast and cost-effective raising of capital. When it comes to time benefit, an IPO usually takes between 6 to 9 months, while ICOs can be done within a few days. As for cost benefit, an average IPOs cost between 5 to 7%, while ICO platform generally takes about 5% fee. Moving on to the ICO system design. The initial coin offering service allows fundraisers to publish their campaigns to raise capital and prospective investors interested in those projects to contribute funds in exchange for the project's token. The following diagram here illustrates the possible user interaction with our smart contracts deployed. This whole process relies on 3 different smart contracts. First, we need an ICO factory contract. Fundraisers can interact with these contracts through our user interface to create a new campaign, which comprise an escrow contract and a My Token contract. The second contract is the escrow contract itself. Both fundraisers and investors can interact with it. For example, fundraisers are allowed to cancel the ICO campaign or adjust the parameters of the campaign if no one has contributed. The third contract is for the underlying token sold in exchange for funding. This is an independent contract that adapts functions from the ERC20 interface, which is the technical standard for fungible tokens created in the Ethereum blockchain. The escrow contract interacts with the token contract to distribute tokens upon a successful campaigns. As you can see from our diagram here, a general flow of the system will start from the fundraiser creating an ICO campaign through the create functions in ICO factory contract. Upon contact with ICO factory contract, it will then generate an escrow and My Token contract, these two here, to facilitate the ICO process. To contribute, investors will contribute to the campaign through the deposit funds function in escrow contract, and then once a campaign is successful, the funds collected in escrow contract will be transferred to the My Token contract, where fundraisers can withdraw funds and tokens can be distributed to the investors. Now that you have a rough idea on the system design of an ICO, it is time to get our hands dirty on implementing it on Remix IDE. I'll be explaining two versions of implementation, one without the utilization of OpenZeppelin contract and another one that leverages on OpenZeppelin contract. The later one is faster and smarter, but the former one will allow you to gain a better raw understanding on what is going on behind the scenes in a more detailed manner. So let's take a look at the raw implementation. The MyToken contract is used for the initialization of an ERC20 token for crowdsale. This contract defines a set of functions according to the ERC20 standard. The main operations handled by this contract include getting the total supply and balance of tokens and the method used to transfer them. It contains the following functionality: create or read the number of ICO tokens, get token balance of owner, transfer tokens to another account for secondary sales, approve delegate to withdraw tokens, transfer tokens by delegate, and lastly, withdrawal of fund raised upon successful ICOs. Here, we first define the interface called IERC20. What we're doing here is that we're defining all the functions and events that this interface will contain. So when we create the token contract here below, we want to say that this contract contains the interface of IERC20. So what this means is that our contract will have all the functions defined earlier. So within this token contract, we first initialize all the necessary variables that we will interact with. So the name, symbol, decimals, issuer, balances, and total supply variable will be used in our constructor here, which is initialized when we deploy the contract. The name is the coin name, the symbol being the coin symbol, decimal to set the rate of how many tokens per ITO, total supply to indicate the total number of coin available to mint, issuer represents who is the creator, and a balance variable to record the total token balance of each owner account. Once this constructor is initialized, our token will be ready to use. All's left in this contract is to create helper functions that allow us to interact with the token. Some of the essential functions we will need are: number 1, the total supply function, which returns the number of tokens allocated by this contract. Number 2, the balance of function, which returns the current total balance of an account that is identified by its owner's address. Third, the update mapping function to update the balance record when there is an activity on mint or transfer of coin. Fourth, the transfer function to transfer tokens from one another to another. Fifth, a payable function to allow this contract to receive funds. Sixth, lastly, the withdraw function to allow creators to withdraw funds upon successful campaign. And that's it for our token contract. Our escrow contract, which is used to facilitate the crowd sale process. In this contract, we manually set up a safe math library here with the operators of add, subtraction, and divide to set up an industrial strength escrow contract when dealing with mathematical operations. Next, similar to what we did in token contract, we first initialize all the necessary variables that we will interact with. First, active is of a Boolean type to keep track if the ICO is still active. Issuer of address type, which indicates the issuer of the ICO, person who created the ICO and who will receive the proceeds. Third, the platform address, which indicates the address which will receive the platform fees from users using your platform. Fourth, the token address, which indicates the address of the token contract. Fifth, the end time, which specifies when does the ICO periods end. Sixth, the goal, which is the target of how much does the issuer wants to fundraise. 7. The current funds, which tells you the current amount of fundraise. Number 8. The funds by user, which tracks the total funds submitted by each user. 9. 2 coins, which tracks how much coin each user owns. 10. Funders keeps a record of everyone's address that contributed. 11. Can withdraw is of a Boolean type, which indicates if the funds can be withdrawn. 12. Coin to indicate the token which the crowd sale is bound to. 13. Price to indicate how much the token costs. 14. To give out, which indicates the total supply of the coin left for sale. All of this will be initialized in our constructor. Once this constructor is initialized, The crowd sale will be linked with the token we created to facilitate the ICO. Once the escrow contract has been created, both the fundraisers and investors can interact with it. For getter functions, we have getInfo function to get the information about the crowd sale initialized. The getToGiveOut function returns us the number of tokens available for sale, and getCurrentFundRaise tells us the current fund raise. With the cancel function and change price function, fundraisers are allowed to cancel a campaign or adjust the parameters of the campaign if no one has contributed to the campaign. Investors are allowed to contribute funds to the campaign through the contribute function. All contributed funds are held in this contract and cannot be withdrawn by the fundraiser under any circumstances. At the end of the campaign, if the campaign fails to meet its funding goal, an event listener will automatically trigger refunds to investors. If the campaign is a success, the funds will be moved from the escrow contract to the token contract where the fundraisers can withdraw funds from. Holding funds at the token contract opens up the possibility of a governance system for the ICO. In this contract, extensive validation and checking are done to ensure the rightful execution of functions to prevent the tampering of fund and contribution records. For example of such, only fundraisers can end or cancel the ICO. Refund only possible for a failed campaign, and insufficient supply of token for sale. The contract also calculates the number of token contributor gets based on their contribution amount that is also subjected to a platform fee per funding. And with that, both the token and crowd sale contract is ready to be created by our ICO factory contract. Upon receiving a request to create a campaign from the fundraisers, the platform interacts with the ICO factory contract to initiate an instance of the ICO and token contract. This is a single deployer contract that creators first interact with to create, configure, and deploy their ICO and token contracts on the blockchain for their crowd sale campaign. During deployment, this contract will create the other two contracts, each with an associated address, and temporarily assume both the contract owner and minter roles. The coin address is associated with the My Token contract, and the ICO address is associated with the escrow contract. By using the addresses provided for these contracts, we can then link the on-chain contracts with the code written for the contracts. Since the contract is publicly available on the blockchain, anyone could simply make a call to the ICO factory contract to initialize the ICO contract. To prevent unauthorized calls to the contract, we have implemented a check for whitelisted addresses to ensure those who have not been verified via KYC will not be able to create a campaign using the factory contract. It also has the function to add, remove fundraisers to the whitelist. With these three contracts in place, let's go ahead and test the system as shown in this diagram in our slides. Let's first deploy our ICO factory. Now, in order for us to create our ICO, we will first need to add the creator address into the whitelist list as part of our KYC effort. So let's go ahead and call the add to whitelist function with our address. Next, we check that indeed our address is included in the whitelist by calling the whitelist function. We see that it is true. Next, let's go ahead and create our ICO project with the create function. Issuer will be our address. ID we will set to 1. Duration of the crowdfund will last for 5 minutes, which is 300 seconds. Goal value, we will set it to 5 Ether, which equates to this number of Wei. Price value, we will set per coin to cost 1 Ether, which equates to this number of Wei. Our coin name will be BNB Chain, and our coin symbol is BNB. Our total supply for this coin shall be 10, and let's click create. Now, hit on the coin address and ICO address button to retrieve the contract address of our escrow and my token contract that was created to load it up on our remix. So I will copy these two addresses and load it here. And now we can interact with our token and crowd sale contract. Take note, our crowd sale only lasts for 5 minutes. Let's first explore our coin contract. We can verify that all our input was correct. And that the contract owner owns all token at start of the campaign, which has a supply of 10. Now, if I was to use another wallet address to inquire on how much does this address own, I should get 0, as this account has yet to mint any token. Now, let's go and explore our crowd sale contract as a contributor. In this contract, we can inquire on the crowd sale details, such as the current balance of fundraise, which is 0 for now, how many tokens are available for minting, which is 10, and that the goal of this crowdfund has not been met yet. So let's go ahead and contribute to achieve the ICO goals. Let's have this account to contribute 3 Ether and another account to contribute 7 Ether. The goal of the crowd sale to raise a total of 5 Ether will be met, and the supply of the token available for mint will become 0. Current balance of fundraise will be 10 Ether. We can then check how much funds each contributor has contributed here. Now, the creator can end the campaign successfully, and funds will be transferred from the escrow contract to the token contract for funds withdrawal. We will then withdraw the funds, and as you can see, our wallet amount has been increased by 10 Ether. There's more we can do with these contracts, such as transferring of tokens from one account to another, but what we just went through is really the essential process of an ICO as shown here. So that's pretty much it for a raw basic implementation of an ICO. I will now show you an alternative implementation that utilizes OpenZeppelin contract. The following implementation conforms to the ERC20 token standard from OpenZeppelin, which allow us to develop our smart contract efficiently and securely. As you can see from this contract, there are way less functions created as compared to the previous implementation, and that's because we're actually leveraging on OpenZeppelin contract that has already provided all the functions needed to facilitate a crowd sale. You can check out part 3 of the series for more information on OpenZeppelin contract. The system flow works the same way as what we have just went through, so I'll just briefly explain the contract codes. For our token contract, first, we import the 4 OpenZeppelin libraries we need to build the token: the ERC20, the detailed ERC20, the ERC20 mintable, and the ERC20 pulsable. ERC20 provides all the basic ERC20 functions for us. Detailed ERC20 allows us to pass some constructors arguments to customize the token. Mintable allows us to create new tokens in the crowd sale instead of having a fixed total supply from the beginning. And lastly, pulsable allows us to freeze tokens transfer during the crowd sale so that investors cannot dump them while other people are still buying them. My token contract will inherit attributes and functionalities from all these libraries. Next, we create a constructor that gets run whenever the contract is migrated. This constructor takes arguments that customize the token. These arguments get passed into the detailed ERC20 contract. For our crowd sale smart contract, we import the crowd sale smart contract library from OpenZeppelin, and we inherit from it in our contract. Next, we add some constructor arguments to our smart contract and pass them to the crowd sale smart contract library. Here is an explanation of the arguments. The rate, which is the rate at which tokens are purchased in the crowd sale. If the rate is 1, then one way buys 1 token. If the rate is 500, then 500 way buys 1 token. Wallet, this is the account where Ether funds are sent in the ICO. Token, this is the address of the ERC20 token being sold in the crowd sale. Importing minted crowdsale will allow us to mint tokens whenever someone purchases them. Next, we add a timer to our crowdsale with time crowdsale. In the constructor, we will add an opening time and a closing time. We will only allow investors to purchase tokens within this time window. Lastly, refundable crowdsale to add refund support to the crowdsale smart contract. With this feature, we will create a fundraising goal. If the goal is met, the wallet will get to keep the funds and investors will have tokens. If the goal is not met, investors will be able to claim refunds. As for the deployer contract, it does the same thing as the raw implementation, where it will deploy and link the token and crowdsale contracts. So as per usual, let's deploy these contracts and see what are the functions available for us to call. As you can see, there are lots of functions for us to use despite us not writing any of it in our codebase. These are all functions provided by OpenZeppelin as we extend our contracts to theirs. And these functions can be integrated together to facilitate the system flow of an ICO as seen here. To conclude this video, ICOs provides an alternative opportunity for startups to receive capital compared to traditional funding approaches. ICOs are more accessible to startups as they do not require a huge amount of funds to begin with, and all transactions are done in the blockchain, which promotes transparency. With the use of ICO, it solves the problem of the long process taken for companies to pitch to investors and receive funds, and potentially increase access to capital due to ICOs being unregulated. However, ICOs still have their risks and challenges such as money laundering, fraudulent companies wanting to launch an ICO, and their volatile nature. These risks and challenges will need regulations to be put in place and good design of smart contracts to reduce vulnerabilities to bugs, to reduce risk associated with investors so that they would buy into ICOs. And with that, we've come to an end to this video. I hope this series has helped you to build a simple real-world crowdsale on Binance Smart Chain that can be used to raise funds in a real-world ICO. If you have any questions or input, do comment at the comment section down below, and remember to like and subscribe. Have a nice day.